I'd like to welcome everyone. Since everyone is here, let's get started. Scientists investigate that which is already is. Engineers create what it has been never. On behalf of Electrical and Electronics Department, Office of International Relation and Collaboration Cell with IEEE MGR Student Chapter had organized an international conference on electrical vehicle and engineering in medical science. The topic of today's session is recent programs in Magnesium Ion Battery. Now I call upon Ms. B.R. Shankari, Assistant Professor of Department Electrical and Electronics Engineering, to introduce the speaker of today's session.
Good morning, one and all. My warm welcome to everybody gathered here. I am very delighted to welcome you to the second day of the International Conference on Electric Vehicle and Engineering in Medical Science. It's my pleasure to introduce our chief guest, Mr. Satyanarayanan Kannayan. He has completed his undergraduate degree in aeronautical engineering from prestigious Anna University in the year of 2011. Later, he has completed his master degree in Karpagam University, Coimbatore in the year of 2014. Currently, he is doing his doctoral degree in mechanical engineering from the National Taiwan University of Science and Technology. His research interest focuses on the preparation of nanostructured composite material for hydrogen storage and sensing applications. Also, it is to be noted that he was a faculty member of Department of Aeronautical Engineering, Sri Krishna, Ramakrishna Engineering College, Coimbatore, till the year of 2019. Once again, I am welcoming you, sir. We are very eager to hear your presentation, sir. Thank you, sir.
Okay. Can I start right now?
Yes, sir.
Okay, fine. Thank you for your introduction. But my name is not Satyanarayanan, it's Sathiyalingam Kannayan. It's okay, fine. There is a mistake in my name. Okay. Let's start right now. Okay, that is good morning, right? Yeah. Hi, everyone. I don't know how many students are there or how many people are there. Okay, good morning to everyone. My name is Sathiyalingam Kannayan. Okay. Are you guys seeing my screen right now? It's something like. Is it
Yes,
okay
sir.
right now?
Okay, sir. Okay, sir.
Okay, fine. Okay. I hope all are doing good in India. No, weather is very bad in India. I came to know from my family members. So okay, take care all, and thanks for inviting me for this international conference. This is actually my first talk in an international conference. Okay, you gave me some small introduction. So currently my research is in magnesium composites. So my application part is in two areas, something like in hydrogen storage, and also some part of my material is going to be in battery. So only I took this topic for you guys. So let's jump into today's topic. Okay, and this is my outline of my presentation today. uh, why we are here today actually. So we want to know what is the importance of the battery, why battery is needed, and there are different types of batteries till now. We have to look into what are the different types. It's something like from the past to till now, and after that something like the new field of research interest now in all over the world is going on. So that is magnesium ion batteries. Apart from lithium ion batteries, magnesium ion battery is also an important research. Current research it is. So, and my talk is more about materials. So it may be something like related to chemistry, or it may be like that. So I'm not completely into electrical stream or domain. So it may be something like what are the materials used, what are some difficulties, what research is going on. So by using those some information, you guys can get an overview of what is happening in the world. And finally, I will stop with something like what are the challenges, what we have to do, what is it, upcoming researches. So this is about my outline of my presentation. So the next one is there is a need of battery. Why we need battery? Okay, as we all know, something like there is a global warming, and we need to reduce the use of fossil fuels. Something like as you guys know, what are the fossil fuels? Something like coal, oil, gas. So there must be something like reduction of using those things. So we are going to jump into renewable energy sources. So all over the world, people are working on renewable energy sources, something like solar, or it may be wind, it may be hydrothermal. There are different works they are working on it. So in those all things, something like electricity, this electricity need to be stored. So there is a device that is called battery. So there comes the importance of battery, and there is a need of battery to store electricity. So after something like 1970s to 1990s, the storing of batteries only electricity is happening. So their application is only for something like residential applications or industrial applications. After some times of 2000, uh, automobile industry is something like they are planning to use electrical vehicles. So the basic research is started by Toyota, and they have did with some magnesium ion batteries. They have not succeeded as much they can, but they were something like pioneers. They were started actually uh, using of magnesium ion battery in the automobile. So what will happen? Something like if you use electrical vehicles with the batteries. So main thing you can have something like you don't have any pollution. You can see on the other side something like it does like two sides of the coin. One side you can see there is no pollution, but on the other side there is a drawback. Something like if you see the manufacturing of electricity, there it's something like um, there are also some problems out there. So that is also to be addressed, but here I'm not going to talk about those things actually. So then the next why we need batteries for electrical vehicles is the cost of the fuel. Nowadays it is getting higher and higher. If you consider in India now, it is something like petrol price is more than 100 Indian rupees, and something like diesel it's more than 100. I don't know exact figure, but now it's something like approximately 90 to 110. So the price of fuels also getting increases, and this fuels getting from the nature or from the oil wells, it's also getting decreases. So there is an imbalance. So uh, in order to maintain this imbalance, we need a battery to store. We need electric current. So how can we store this electric current? Is in the form of battery. So this is the reason. Something like rising cost of oil and gas is the main one, and then pollution, energy efficient demand for energy. And this is what I want to talk about it. The next one is um, this is actually okay. There is a different graph in it, but I just replace it. I didn't change it. Okay, fine. Let's keep this graph, and I'll talk about right now. Actually, now in the world market, there are something like two big uses of electricity. One is for transportation, and one is for electricity grid. Okay, so it is something like survey from 2030 from uh, Energy Institute of America. It's something like they say there is a energy demand in these two areas. One is transportation; it takes around something like 28%, and electricity grid is of 39%. So there is a transition in it. So battery plays an important role in it. If it is a transportation, sure there is a battery. So in a electricity grid also they will store the electricity and they will supply to the residential, non-residential or commercial areas. So there is something like need of battery here. That is, it's a major part. It's 39%. So when you look into personal electronics, something like what are all the personal gadgets you guys have? What is it? Something like mobile phones, watches, everything. It's all of personal electronics which are using the batteries. It's very less than 2%. So half of the things were something like if were used for transportation and electricity grid. So what happens right now? It's something like there is a transition or something like one end to the other end. So we need to have different batteries or different capacity of batteries to store this electricity. And the next one is different types of batteries. Mostly mostly in the 20th century, the advancement of energy storage plays a major role. So because of this advancement of energy storage, they need to store a lot of electricity. So this battery, the chemistry of battery is getting developed in 20th century. So there are different types of rechargeable batteries now in the world. Actually, it has something like it's there before. Now it has gone, and the new replacement of new batteries are coming into the world right now. So as we all know about something like lead acid batteries is the oldest one. So whenever you talk about this batteries, the main thing is something like is their lifetime and energy density, how much energy density, and for how many years it will come, or how many months it will come, or you can say it in a cycles. So I showed you some different types of lead acid, some types of batteries here. So uh, at the end you can see the lithium ion battery. It has when you compare with energy density and when you compare with cycle lifetime of batteries, this actually it's something like it stands at the top. So it is more than 5,000 cycles it can withstand, and the energy density is up to 300. So nowadays the batteries which are all used for in a mobile phones or in the cars, even in the Mars rovers are also used lithium ion batteries. So those batteries has these good features. So only now in the world, lithium ion battery is it's something like it plays a major role. So let's talk about little about lithium ion batteries. Uh, Before into lithium ion batteries, there are we have to know what is why we are using this lithium ion batteries. This lithium is a monovalent single vacancy element. So this is lightweight and rechargeable batteries. So because of those the good characteristics, it is emerged as an efficient device. It is it can be used both for what is it electrical vehicles, cars, or even now in Taiwan I saw some buses were running with electricity. I don't know about in India, whether in Delhi I came to know that the buses were running with uh, electricity. I don't know, with something like with batteries. Okay, so but I saw in Taiwan the buses were powered by using battery power. So now it's changing a lot from from gasolines to electricity. So this lithium ion battery plays an important role in it. Okay, so how this lithium ion battery working? So you guys have to know about it. Usually the battery will have a cathode, anode, and an electrolyte. So I'm going to stop here for a minute, then we can have a video how this lithium ion battery works. Okay, usually you can find it in YouTube, so just it may be something like 3 to 4 minutes, then we can continue our presentation. Okay, am I something like the audio of the YouTube video is okay? Can you hear? Is there anyone to hello?
Sir, we can hear you, sir. It's clear.
Okay, fine, thank you. Okay, I think you guys have a basic idea how this lithium ion battery works. So this is the same principle which is used for magnesium ion battery also. So only something like I I just showed you a basic video how it works. So let's move on and There are different types of lithium ion battery also. Even small something like there are different types of batteries. In lithium ion, inside it there are different compositions, something like different anodes or different cathodes based on they have named it. So there are 6 different types of lithium ion batteries are most probably using in the world right now. So those batteries are selected on the basis of voltage, how much voltage it is providing, and their lifetime. It's something like cycles, number of cycles, and how much current rate it can provide, and at what temperature, it is the maximum temperature this batteries can withstand, and the specific energy, something like how much energy it can be stored in a battery. So based on those 4 or 5 criterias, these batteries are arranged here. Okay, here if you see the maximum temperature is something like lithium iron phosphate batteries. So it can withstand up to 270 degrees centigrade. So their application is some you can use it in a hot places or the temperature where it's more. You can use it there and you can store the store the electricity there. So it also depends on how many cycles. If you see the maximum cycle is lithium titanate oxide LTO battery is something like it can withstand up to 7,000 cycles. So it has some advantages and some disadvantages. So there are different criteria you have to look into it, and based on your requirements and for the betterment of the usage, you have to select the batteries. So these are 5, 6 or 7 types of lithium ion batteries. Next is we are going to jump into magnesium ion batteries. So you have to know what is the reason why we are going there. So in order to explain those things, the first something like lithium ion battery energy density has reached to the theoretical limit. So you can't increase above this particular limit because its theoretical limit is the highest limit. So we have reached up to the theoretical limits. So if you add some different materials also, you can't get it more than that. So now the lithium ion battery is the cycle, so its graph is getting down. So we need to see, or we need to find the betterment of new batteries. So magnesium ion battery is into attack. Before that, I want to talk about little about this graph. Okay, this graph is something like it states how the lithium is transformed to battery, something like for 30 or 40 years actually. So this blue line indicates the cost. Something like in 1990s, uh, it's more than $3,000. Now it is gradually reduced, and it is now probably within $500 per kilowatt per hour. Okay, so now the cost is also getting decreases. And see the energy density. This red line is an energy density, so that is getting increased here. So this looks very good, because the energy density value is high and the cost is getting low. So why we are going to jump into magnesium ion batteries? So there is a big reason in it. So that reason is called dendrites formation. If you are very deep study about batteries, you can see there is a formation of dendrites in the anodes. So because of those, dendrites are nothing but there is an extra layer. It forms in anode section. Because of those dendrites, the lifetime of the battery gets decreases. So nearly 40 years, the researchers were working to get rid of this dendrites completely from lithium-ion batteries, but it is little tougher process. So we are unable, they are unable to completely get rid of dendrites in it. So we need some different technology in it. So let's move on to it. Something like magnesium ion batteries. So before going to magnesium ion batteries, now let's talk about what is magnesium in it, and uh, what are what are the properties of magnesium. So the first one is it is a bivalent uh, property. So it has two electrons in it, and this magnesium is a non-toxic one, and it is the eighth abundant element on the earth right now, and the density of magnesium is 1.74. So it is also a light metal. So everything is satisfied, something like, because the battery need to be less in weight, and it should be non-toxic, and high theoretical volume capacity it must be there, which means specific density or energy density value is little more. And magnesium is, it can withstand up to 760 degrees centigrade. So it is highly thermal, its thermal stability is more. So this is it is a better choice, or it is an alternate choice for lithium ion batteries. And then the protection of lithium magnesium when compared with lithium in 2012 is 20 times is higher. So every comparison with lithium, it works well. So then when you're going to for a battery, we have to compare these key parameters in it. So one is price. When you think about price, see, lithium is something like 64.8 thousand per ton, dollars per ton. But when you compare with magnesium, it's something like only 2.7. So then this volume capacity also, when you compare with lithium, it is little more. But gravity capacity is something like, it's low. Okay, it is something like 2206 when you compare with uh, lithium. This is because the atomic number is little more for magnesium, so it is little like, it is heavier than lithium. So there the value get reduces. But this is something like, it is an alternative material which is nearer to lithium. So then the next thing is something like lithium. It easily react when you keep it in the atmosphere, or if you put it in the water, it will easily react with it. So lithium it's not stable in air, but magnesium is also, it's something like, when you keep it for a long time, it is not stable in air. But when you keep for a short time, or if you pack it into a battery and if you keep it, there is no problem with it. So stability in air is a important parameter. Magnesium is overruled. And the dendrite formation, you can see dendrite formation in magnesium. It's not like in lithium batteries. So I will talk about at the last what happens then, how can we reduce this dendrite growth in it. So these are the key parameters uh, which help you, something like magnesium is a very good alternative material for magnesium ion batteries. So, and the next one is not only keeping all those things in mind, and if we can talk about this magnesium is better. The next important parameter is something like recycling. If you look into this periodic table, you just see the lithium it is below 1%. It is recycled. So the availability of lithium is also, it's very less. So, and the recycling is also less. So if you look into magnesium and just look at something like 25 to 50%, yeah, it's recycling, and everything is positive with magnesium. So magnesium, here we can it can confirm it as of material properties, and it's something like end of life recycling of a particular material. Magnesium plays an significant role in it. So next one is the working of magnesium ion batteries, it is similar to what we saw in a YouTube video. It is similar to lithium ion batteries. Where it is lithium is used, we use there it's something like magnesium and different types of cathodes and different types of electrolytes. So working is as similar as lithium ion batteries. Only this materials has changed here. Okay. Now we are jumping into main part of today's talk. So usually in the batteries you can find there is three different types of materials, or the three different parts are used. One is anode, one is cathode, one is electrolyte. You guys, we are studying from a school, and so we know about what is anode, what is cathode, and what is electrolyte. Okay, here what are the different types of materials used, and how these materials behave, and what are all the something like these materials has problems, why it is not used, we can discuss in the further slides. So now before going into anode what basis we have to select one. Usually if you select any material for any application, it must be cheaper one, it must be safe, and it is eco-friendly. So these are all three things you have to look into first. It must be cheap, and you have to find it everywhere. It must be abundant. If you took something like rare metals, it can be used only for research purpose, but you can't use it for daily purpose. So it must be, you have to find it cheap and enormous materials. So and other one is a reversible property must be high for anodes, and it has to be something like it has to be diffused with high with magnesium. The anode material, it has to diffuse with the magnesium so faster. So the fast magnesium diffusion property is also taken into consideration. Usually, if we talk about batteries, it should have high energy density. So and the next one is it has to go with other components also. If you keep anode as a uh, is a, this anode has to work with this cathode and the electrolyte which we put it inside the battery. If it doesn't work, then there is a battery get lost, or there will be short circuit of the battery. So these are all some important parameters you have to look into it before selecting the anode. So when I go before okay, there are two different types of anodes, that is uh, by using alloys compounds, and the other one is pure magnesium metal. They are taking magnesium metal as an anode, pure magnesium, and they are working on it, or else they have different combination of alloys. It may be magnesium alloys, or it may be different alloys, and they are use it as an anodes. The first one which we are going to see is it's a purely, if it is a purely magnesium metal. Okay, now what we are going to do is, when you take pure magnesium metal, okay, there its storing capacity is, it's good actually, it's very high, it's 3832, but there are some problems in it. So the main problem is it is when the electrolytes which you are using, right, this electrolytes and this the pure magnesium, sometimes it may reacts. Because of this reaction, what happens is this anode, there is a layer, there is like a new layer is, it is something like it's formed on the anode. So because of this layer, this electrons flow, it has been stopped. So nature of this passive layers, it stops sometimes the electrons. So uh, so the efficiency of the battery is also getting decreases because of it's a pure magnesium, it easily react. So and then no dendritic formations are formed, but uh, there will be a small formation. I will show you. There will be small uh, there will be a small layers of dendrites will be formed here. This this is formed actually. This is to avoid there is a different types of electrolytes. If you use a different electrolyte, the in the magnesium metal, there is no passive layers will be formed here. But in a lithium ion, if you can see, even if you're using those electrolytes, also there is a possibility of forming this passive layers because of these layers SEA, and there will be short circuits and everything will happen because of. And main thing is lifetime of a battery will get decreases. The capacity is storing capacity is getting faded. Okay, it's getting gradually reduced after for a long time. So pure magnesium, many researchers were worked on it, and but it's something like because of those problems, they are not completely working on magnesium metals. So they are going for alloy components or alloy compounds. So the first one is something like bismuth based anodes. This bismuth is something like structure is rhombohedral crystalline structure. So this structure is more helpful for this storing of electricity in the battery, or something like the volumetric energy density is little more in bismuth based anodes. So here there is also losses actually, because when the researchers has tested with bismuth anodes, the capacity is getting faded. Okay, this is due to this electrolyte is getting contact with bismuth anodes. So there is a periodic volume change in it for a long time. If you're using for a long time, there is a change in volume. So this bismuth anode also gets faded after a long time. So it is not if you use it uh, after a period something like for 100 cycles, 100 cycles or 200 cycles, their capacity is getting faded. If you consider something like, there is a researcher who did research work on bismuth anode. If it is a pure bismuth, the energy density is something like 257. After 100 cycles, it is reduced to 200, 220. So the specific density values also get decreases here. This is because when it react with electrolyte or the chemicals which are used in the batteries, so there is a big problem. And so different types of alloys they were tested. The first one is with there is antimony also tested. So with the tin they have tested, and making into nanotubes, and they have tested how it works, and or carbon nanotubes with bismuth they worked on it. Still it is under research process only. It is not giving some good results. And this is what the graph it's all about. This is a research actually done by a researcher. So that was I was discussed with the values right now. If you see the graphs, it showed some good. The red one is the researchers which have done it. It's has some good results, but the thing is something like, if you see number of cycles, it is getting reduced. Okay. Next one is the tin based anodes. First is bismuth, that is an alloy, and this is also is alloy compound. So in tin based, the first thing is something like, when you compare with bismuth, uh, there are something like, there are some good advantages when you compare with bismuth. The first one is, I don't know if I said it. Okay, the first one is atomic weight of tin. Okay, tin is lower when you compare with bismuth. So if you consider atomic weight is lower, then the weight of the battery is also getting changed. Then one, and the next one is the recycling. If you see the recycling graph, recycling. Now, if you see with bismuth and the tin is something like it lies in the range of 25 to 50 or more than 50%. But if you look into it, bismuth, it is less than 1%. So this is also, there is a problem when we compare with bismuth anodes or bismuth alloy anodes. So tin-based anodes are better when you compare with bismuth based anodes. So here one is atomic weight, and the availability of tin is also comparatively more when with bismuth. Okay, then it has higher energy density values. And now, based on the researchers, they have found something like the tin with antimony alloy. Okay, this is what the researchers has working on it, and they have found it. The kinetics got improved in the anode because of this alloys, and the specific and this is a graph. Okay, I think you guys can see it. The first one is the kinetics gets improved. Okay, this black one, see if you get, there is something like there is an increase in the kinetics here, the A. And the B1 is something like, if you see this, the energy density or energy capacity get increased when you compare with a pure tin. Okay, then the rate of capability and what is it, and the energy storage retention is also comparatively it is more when we compare with pure one. Okay, and if you run it for more than 200 cycles also, it is not it's not fading very faster. It is something like it is okay when we compare with bismuth. If you compare with this bismuth, you see uh, it is something like the cycle is getting very faster. It is getting very faster here. So here in the tin, it's a gradual reduce. So tin plays a major role in anodes of magnesium ion batteries. So what are the different types of materials? Tin based materials were used in magnesium ion batteries or tin powder, then nano sized, if you ball mill the tin particles, and then they're making into slurry, and they use it as an anode. And there is tin antimony alloys also, they are working on it. Before that, it's something like if it is in an alpha phase, it works well when compared with beta phases. So next one is this is a recent research actually in anodes, titanium based anodes. They are working on it. This is also, it's a new research. You don't get it more data on it, but when you compare with other anodes, it has something like the performance is also good. And titanium, the anodes can be prepared easily with titanium, and efficient charge transport. It is able to transfer easily this what is it, electrons. So titanium plays an important in magnesium based anodes. This reaction is also comparatively lower when compared with other anodes. So very few papers that have started publishing in 2020s. So this is one important research area, research gap in magnesium ion batteries. So if anyone wants to work on it, they can start working on this type of anodes. If they have good results, then it is useful. So okay, there are different types of materials which are used for titanium anodes. One is sodium hexatitanate is used, and it is used as a nanowire, and titanium with niobium pentoxide. It is also, it's nanofiber is also, it's also checked. Okay, then they have some good results actually. When they were tested with sodium hexatitanate, the interlayered of spacing of a particles is little more with sodium hexatitanate. So because of this, interlayer spacing distance is more, and the magnesium ion storage and diffusion is also good. So the initial testing, the results were seems to be very good actually. So this is about titanium based anodes. So this is actually this is a research area. So you guys can work on it. There are different types of materials. Other different materials were used. So these are all very basic researchers. One or two researchers worked on it. It's something like it's a comparison. Okay, one is with the boron B40 and indium and lead. They were used it. So they were trying actually which one is it works with. As per surveys and literatures, we can say about tin, anodes, and titanium is also behaving well. So many researchers are working on it. So if you see in the periodic table, this anode, if you see in the fifth A group elements or four A group elements, 3A group elements, all on all areas, people are working to find which is a better anode for the future magnesium ion batteries. So it is a good area to work on it if you want to do research. The next one is I'm going to talk about cathodes. There are mainly two types of cathodes. One is conversion and the intercalation cathodes. I think intercalation you saw it in YouTube, something like the material is you are putting between this graphite and the lithium is putting inside. So when you connect when you start working, this lithium will come out from there. So in the similar way, there are different material. Intercalation is also done, and conversion type. Each are subdivided into other two or three types. Okay, let's see into it. Before going there, you need about cathode selection. How to select a cathode. So in the first thing, usually you see something like the cycles, number of cycles, stability, and because cathode plays a major role. So the cyclic ability of a cathode is very important, and there is a fast kinetics. It should have something like it absorbs or it emits, or it should be have some good kinetics in it, and this cathode has to be worked in high operating voltage. So cathode many researchers it's not went deep in cathodes. There are different types, but it's all of something like chemistry related works. They are not mechanical or electrical related works were not done yet actually. So next one is the different types of cathode, right? There is several phase and layered compounds are it comes in intercalation methods. Okay, in several phase, it may be intercalation or de-intercalation chemistry is there. Okay, so uh, that this is a basic formula in it. It is something like it is M. It stands for metal. The capital MS it stands for metal. You can take anything. You can lithium or magnesium. Anything you can take. And this T, which is trans, it may be tin or tellurium or antimony. Anything you can. So based on this formula, the compounds were made and they were tested for a cathode. So this is also this actually majorly used in lithium ion batteries. So there it is performed well, but when it is taken to magnesium ion batteries, so the results are it's not up to the mark for it. So but people are working on it. It gives some good result for it. So this is one, and then the next one is in this, and I want to talk about this. When you talk about this combination MX, MO6 and D8, okay, and here the 4 electrons are exchanged in the while it is a reaction. There is 4 electrons got exchanged, and because of this 4 electrons, this magnesium 2 plus ions, uh, it helps something like it movements of this magnesium ions. So this electrode, this not electrode, this cathode has a good discharge rate because of this. What is it? 4 electron exchange and movement of this magnesium ions. So the discharge rate is very good for this combination of cathodes, and the cycling performance at the room temperature, it performs well. So, but this cathode is very famous in lithium ion batteries. Researchers are also fine. So layered is nothing but keeping layer by layer, and inside this there is material. So the layered structure cathodes are mainly, it's a two-dimensional transmission channels, and inside this magnesium 2 plus ions are inserted. So this is also a major. Here there are three different types of materials that are used for this. One is transition metal oxide, and metal sulfides they are also used, and carbides also they can use. So this, according to me, here we can, if you are a mechanical engineer, you can see this transition metal carbides can be put into composites, or metal transition metal oxides can be put in a composites. And if you work on it for a battery related application, it is a very good research. Still now, very few papers were published related to this layered transition materials. That is, I'm talking about related to mechanical or electrical. If you, this is a good area of research, you can see it. Something like you can take any material from here, you can add it with magnesium or magnesium alloys. You can make basic steel casting, and you can make a material, and you can take it for a electrochemistry part. That is something like you can get some good results. So the next one is polyanion batteries. This cathodes, not batteries. Sorry, it's cathode. Polyanion cathode is something like three-dimensional network structure. This one layer one is a two-dimensional structure, but this is a three-dimensional structures. So here also they are using transition metals. We have tested from different types of transition metals. And the reason for this cathode is it also behaves good because their the covalent bond between those and this polyanion, these materials, is very strong. So because of this, this has something like good property for being a cathode. Okay, then what are the advantages with this polyanion cathodes when compared with others? So this has a stable structure, and there is something like the induction effect between the materials or electrolytes and the cathodes is very good. So this polyion is also used in lithium ion batteries. So they made a little changes here. See, this is a compound Li lithium. This this can be changeable. This is phosphorus P and O4. This is a combination which is used in lithium ion batteries. So now here for magnesium ion batteries, they just replace the lithium. Li is replaced by magnesium, and this phosphorus is it's replaced by and silicon. So this M can be maybe something like manganese, any metal you can use it. So they make the material in this composition, and they start working for research. So all major cathodes or anodes are from lithium ion batteries, and they are making small changes related to magnesium related to magnesium ion batteries. So they are testing. They are all were something like in a test phase or in a research lab phase. It is not into a product still now. So this is something like a recent one, the sulphur cathodes. So sulphur cathode is uh, it is also used in lithium ion batteries. They are also tested actually, but in magnesium ion batteries it showed some good results. So here this theoretical energy density values is twice as that lithium ion batteries. When they tested, they got some good results. And this it is actually it is it is something like it's in the starting phase of the research. So there is no uh, big research works are done with this magnesium sulfur batteries. But with this actually this stage, this material actually behaves very good for a cathode. But when this electrolyte and this cathode directly meet with, okay, then there is a problem with this sulfur. So there may be something like short circuit, or it may be sometimes it maybe leads to blast. So the safety concerns are also taken into consideration for this. What type of electrolyte we want to use, we want to know which electrolyte it will not react with sulfur. So based on knowing that electrolyte we have to use in this battery when you are using sulfur as a cathode. So this is one important thing you have to consider when you take sulfur as a cathode. So next we are going to move on to electrolytes. Electrolytes, there are two different types of electrolytes. It's a liquid one. It may be like on water, or it may be some solid state. Solid state, when you consider it, is something like composites were used for it. Some organic solid state electrolytes also used. This is a famous one which is used in lithium ion batteries, but this is also used here in magnesium ion batteries, Grignard based electrolytes. This is what I want to explain to you. I said I will explain the latter. So here, this is something like when you use conventional electrolytes, the anode or cathode, it may be anode, something like uh, this peaks where like this materials were deposited on it. So because of this, the reaction between these two, it will not be good. So when you use this as an electrolyte, what will happen is this all get dissolved by this electrolyte. So then there will be no dendrites. So this is the major advantage of magnesium ion when you compare with lithium ion batteries. This even though this uh, anode and the electrolyte will be, what is it, mm, Grignard electrolytes, but there is a formation of dendrites in it when you use for a long time. So this electrolytes plays a major role. Okay, so this electrolyte has a formula that is Rmg. This is magnesium, and this X. The R may be alkyl or aryl, and the X may be chlorine or bromine or any halides. So this electrolytes plays a major role, and this electrolyte has some. Hold on for a second. I will come back here. Okay. This electrolyte has some good characteristics. Ionic conductivity is a little more here. So while doing electrochemical testings, the stability of a electrolyte is also good. So it has low volatility, and it has low flammable nature. So the toxicity level also is something like it's also less when you compare with other electrolytes. So the next one is boron containing electrolytes. Uh, this is uh, this is one important electrolyte, because usually in the magnesium ion batteries, at the bottom or at the side, something like, because of these electrolytes and these anodes where cathodes are using, there will be chance of corrosion in it, and the material will get corroded. So to avoid this corrosion, this boron containing electrolytes is, plays a major role. So this is a combination of electrolyte magnesium and BH4 too is used commonly. So because this is something like it act as a reducing agent. So it reduces something like contamination, it reduces the corrosion. So this is very good for electrolyte, and the electrochemical stability is also, it is very good in this combination of boron. When this is used, this BH4 leads to low anodic stability. So because of this, this electrochemical stability get improved. So this electrolyte is also they are doing research on it, but this is, as far as now, it has some good properties. One is it will not allow to form corrosion, and the contamination is get reduced because of this electrolyte and good electrochemical stability. So the last one is something like solid state electrolyte. This is only very few people has done research on it, and they have tested with different types of materials. Okay, they have tested with polymers, and they have tested with different types of oxides. So this is no big data or many researchers. I didn't get on. Only few papers are working on it. Few authors were worked on it, and one author is from India who worked on this materials oxyethylene, polyvinyl, this PVDF and HFP. These are all chemistry names. I'm sorry for it. Completely, it is a material oriented one. So this is also a major field in electrolyte, because not only anode and cathode is so important. If there is no electrolyte, then there is no good battery. So as far as something like research papers and all my studies, I saw these three is still working on it. So if you want to do some good researches related to this, you can take any one topic, you can study on it, you can work on it. So what are the major challenges? This is what I want to say about this. All I discussed a little before, but I put it in here. See, the first one is there is a formation of the passive layers. This is a passive layer. It will usually forms because of this reaction with the electrolyte and this anode. So in order to avoid this passive layers, we found it Grignard electrolytes is a better one. So this problem is solved. So but the other problem is something like this formation of corrosion. See, when it reacts, then at the bottom it get corroded. When it get corroded, it's the material and lifetime of the battery is also getting decreased. This has to be reduced. And there are different types of other challenges is also there. One, we have to find some better anode, cathode, and electrolyte. And when you use this, it's something like, see, this is an anode. When it react with, when it is a pure magnesium, when react with electrolyte, see how it formed. This plating has been formed. Plating, because of this, it is formed like this. It is like a dendrite structure. When you use some good electrolytes, see, even after for 30 minutes, you can see there is not a big formation of passive layers or any different dendrite structures are not formed here. So this is also very important. If your battery, it must be something like as good efficiency, then these factors are also consideration. Apart from this, there is mitigation barriers. There are high and low electrochemistry part. Many things has to be covered. So the different research are in magnesium ion batteries. I think India has not started with magnesium ion batteries. I think so. You guys have got some good opportunity to work on magnesium ion batteries. So before that, this is as a research student, when you compare with from 2000 to 2020, the work on magnesium ion battery is getting increased right now. But still now there is no good solution for anode or cathode or electrolyte. They are still working on it. I think future may be magnesium ion batteries. Thank you. If you have any questions, can ask me. Before
Thank
that,
you,
I
sir.
want to show. Before that,
Okay.
I want to show my university. There is a video. I want to just is there in if there are some students here, they can have some little motivation for them. They can come and study here also, right? National Taiwan University of Science and Technology, headquarters in Taiwan. We are located in Da'an District, Taipei City, Taiwan. We are known as the top university of applied science in Taiwan, which has all kinds of fields and backgrounds. So now we have more than 10,000 students studying with us. These are our mascots, Benjamin and Doug Rosie. If you understand Chinese, you know that contact in Chinese is pronounced like the duck. Did you hear that? Like the duck. That's the reason. We have some amazing buildings here. We have different classes all around our campus. Now, let us show you one of our cafeterias. This is one of our cafeterias. We have a variety of foods to choose from, such as Chinese, Japanese, Ala food, or vegan. If you need to buy this also convenience store here, you can have a tasty food right here for a great price. Here comes my favorite place. Recently, we refurbished our library. You can have a private room to prepare presentations with your friends. If you need to study, you can study here and enjoy the great wine. Although our engineering departments are competitive and with great history, we have diversified our majors such as business, design, and language. Don't forget our sports field. You can play soccer, basketball, jogging, you name it. Our motto is precision work, sincerity, and attitude. Also, we are aiming to become an international university with both research and applied science merits. We may come from different countries, speaking different languages, but we are all studying in the same place, with hard work. I'm studying in Taiwan Tech. We are studying in Taiwan Tech. Hey guys, this is what I want to say. Just a small one about my university. Okay.
Thank you, sir. We are deeply grateful for this session, effort you have put into this session.
Okay,
A few
thank
have
you
asked,
guys.
a few have prepared some questions, sir.
Oh, they prepared question. Okay, how come I no lay presented? Okay, fine.
Scrolls. What's the
What is
battery
the
life cycle?
life cycle? It's about something like for how many years or how many times it can withstand. When you're working for life cycle, it's something like if it is. Wait, I will come with my PPT. Not very internet. This is what I think she's asking me. What is the life cycle like? It's, it's something like its duration or how much cycle it can withstand. That's it. I think so. For its lifetime or lifespan, how much time it can withstand. That's it. I think this is how I can explain it, very simple. I don't have exact definition for it. Whether the battery can be charged anytime, you can charge it anytime. It is a rechargeable battery. It can be charged. It's like it's something like the batteries which you guys were using in the mobile phone. It's also lithium ion batteries, so you can charge it whenever you want. Minerals used in the battery protection. I don't know what type of mineral. It's type of different types of materials. This is what I talked about, different types of materials. And I don't know what is something like, I don't know, who is it, Saranya? The question must be little specific in it. What they're talking about, whether they're talking about a particular material or mineral. I don't know. I don't know what is mineral. What type of mineral she's talking about. I don't know. Challenges faced in current lithium ion. The major one is the dendrite formation. Because of that formation, this anode it gets blocked. So the lifespan getting decreased. All other things are it's very good, but this is the problem. What will replace the lithium ion battery? Okay, this Karthik, I have talked for more than 1 hour. The answer is something like the topic is magnesium ion batteries. How long do the lithium? Is it okay? Lithium battery charge overnight? Okay, it depends on something like. Uh, I'm not I'm not from mobile. What is it? A mobile company. You can charge it. It's not you are to, if it is something like it reaches a maximum percent, you need to be removed. If you are putting too much charge, is also nothing going to happen. If it is full, then it will not get into it. That's it. I think many questions. I really am something like sorry for it. I'm not from a company background. I don't know how it is working. Uh, okay.
Thank you, sir, for clearing our audience doubts, sir.
Okay, I think I have something like 1 hour 46 minutes, 1 hour 15 minutes, right? Yeah, it's 1 hour 15 minutes. Okay. If you want to study in Taiwan, you can just I don't put any my email or anything, right? Right, I will put it in the last right now. If you guys have any questions or suggestions, if you want to talk to me, you can. Um, Hold on a second. This is my mail ID. I think this is more than enough, right? SATHIYALINGAM@gmail.com. You guys can contact me if you want any help related in Taiwan. If I can do it, I can help you guys. It is small work. Is there any question?
No, sir, that's it. Thank you so much, sir. It's my privilege to be asked you to propose a vote of thanks on this occasion. Now I call upon Saranya from Biomedical Instrumentation.
Ah, okay.
Good afternoon to all. I am Saranya from final year BMI. Here I would like to thank our Privilege Department and Office of International Relations and Collaboration Cell for organizing this wonderful section. I would like to thank Mr. Satyalingam, sir, speaker of today's section. Thank you very much, sir, for sharing your valuable time with us. I would like to thank the organizing committee, department faculty members, and students. Last but not least, I would like to thank all the participants for giving us this precious time. Thank you all once again.
Thank you, guys.